Hi everyone, welcome back to my channel TechStoriesOfManojNaidu. Today our problem of the day Leetcode is maximum matrix sum. So range of the problem is medium. Let's jump into the problem statement. See, you have given an n by n integer matrix. You can do the following operation any number of times. Okay, choose any two adjacent elements of matrix and multiply each of them by -1. Two elements are considered adjacent if and only if they share a border. Your goal is to maximize the summation of matrix element. Return the maximum sum of matrix elements using the operation mentioned above. Okay, what they are saying is we can choose any two adjacent elements, just like the highlighted part. Either it might be horizontal or vertical, so that we can multiply two elements by -1, and then we need to add the sum of the all matrix elements, so that the sum should be maximum. To make the sum maximum, we can iterate this process any number of times, like multiplying adjacent elements with -1. The process, the number of times we can do that operation is unlimited, but at last the sum of the matrix element should be maximum. Okay, so we can observe one thing here. Adjacent elements means the elements which are sharing the same borders. Either it might be horizontal or it might be vertical. In that case, these two are the adjacent elements, and these two are also adjacent elements, but there is no need to multiply with -1 because these elements are already positive. So in order to get the maximum sum, it must contain the positive elements. We need to reduce the negative elements. Are you getting this right? As much as we can reduce the negative elements, we can get the maximum sum of the matrix elements. To do that, first of all, we need to count the how many negative elements are there in the matrix. If the number of negative elements in the matrix are even, we can perform the operation whatever they mentioned in the question and make them as a positive by multiplying it with -1. So all elements will be converted as a positive elements. You can see here two negative elements are there. By doing this adjacent elements multiplying with a -1, we converted all the numbers to the positive elements. No matter how many times you perform this operation, at last the elements will be converted to the positive. This is one pattern. When the elements in the matrix is negative elements in the matrix are in odd number like 3, 5, 7, 1, it is not possible to convert all the elements in the 2D matrix to be fully positive numbers, because one number might be leaved as alone because it can't pair into individually. It needs one more negative element to multiply with the -1. If we do these two elements multiply with -1, again this will become as a -1 and it will become +1. There is no use of doing that operation. Even though if we pair these two as adjacent elements, this will become positive and -3 will remain as constant, but the combination of +3 and -3 will become 0 ultimately, and it will reduce the maximum sum. So what we understood here, first case we need to make all the elements as a positive elements, and second case, if any negative elements is left over, make sure that negative element is the smallest element in the matrix, so that we can make our sum as maximum as possible. Okay, this is our breakdown of the problem. First, count the total number of negative elements, and then make all positive elements is positive. What is the resultant of the making all negative elements positive means the positive element contained in the matrix. If the negative elements is an odd number, make sure the least element in the matrix is that negative number, and remaining will be sum of the matrix elements. We can increase the matrix. Now let's jump into the problem. See, we declared one variable to store the final answer and one more variable to count the number of negative elements in the 2D array. And the absolute minimum means first we need to calculate the minimum integer in the 2D matrix. Okay, to find out that minimum integer, we declared one variable and stored the maximum value in it. Okay, so first iterate the 2D matrix. inside that iterations, to iterate the 2D matrix, definitely we need the two nested loops in brute force condition. If not, we can use some other optimized iterative versions also, but that is not that much needed here. We will go through the nested loops. So first of all, add all the elements. I mean, make the elements to the math.absolute. That means the negative elements will convert to the positive elements, and add that positive elements to the absolute sum. And then compare each element with the absolute minimum element. If any element is less than or equal to the absolute minimum which we declared on the top of the starting absolute minimum, then assign that element to the absolute minimum. For that we used the math function here, math.minof. It calculates the absolute minimum which we declared and the matrix element. Why we again perform math.absolute means to reduce the negative sign. First we need to compare without signs, without a positive or without a negative signature. We need to compare the elements. After getting the absolute minimum, we are counting the negative elements, number of negative elements. Okay, and then the loop exits. There, the decision making scenario we faces. If the negative count is even, then we directly return the math.absolute elements of the matrix, because no matter how many times you perform that operation in the sense multiplying the adjacent elements with a -1, if the negative elements is even number, the entire matrix will convert to the positive elements, and we will return the positive sum of the elements as a result. So we know that pattern, we cracked that two possibilities, so we are directly returning the answer. If the negative elements is in odd number, we need to make sure the remained negative element is the least element in the matrix. In that case, we need to remove that particular element from the sum. So from the absolute sum, we are removing that minimum element. This L denotes that the return type is long. So for safe side, we are hard coding this as a L. Now you might get some doubt why we are mentioning 2 here. I will explain you that. See, here number of negative elements are 3. So not an even, it is an odd. So make sure that the negative element remained in the matrix is the least element in the matrix, that is 1. Now count the elements. 1 plus 2, 3, plus 3, 6, plus 3, 9, plus 2, 11, plus 1, 12, plus 2, 14, and plus 3, 17. Okay, 17 minus 1, 16. But in this operation, absolute sum, we are adding all the elements. Okay, so 17 plus 1, 18. So in absolute sum, the sum is 18. To make it minus 1, if we remove only 1 means it will become 17. It is not the right answer. We are adding all the elements and removing 1 from that elements. But here 1 is getting added 2 times. Absolute sum 1 time, and we are removing that -1. It makes +1 extra for the return answer. So that's why we are mentioning it as a 2 times, because the number is getting added 2 times. So we need to remove it for the 2 times. And finally the answer we will get is -2L into absolute minimum, because we are sure that the remained element is the minimum element in the 2D matrix. Let's see by running this one. It got accepted and all test cases got passed. Yes, and it beats the 34.5%. There is no need to take care of this percentage in the Leetcode. It might show different percentages. And if your solution is working fine, then it is optimized for the given constraints. Okay, thank you.